Okay, welcome to the class of the experimental design and data analysis. For this lecture, I will talk about the properties of the data. The first property that I will talk to you is the average of data. In this class, I will talk to you two types of the average. The average of the data and the data with the group of the fluency data. That's why we have individual group, individual data, and group data. This slide show you the formula to calculate the average. This is for the individual data. For the individual data, you use this. Like I talk to you about the basic property of data. This is the average. Average means you summarize the data. That's a summary of your data divided the number of data. This is represented by x bar. That's right. Usually we find the average value, average variable. X bar equal to summation of xi. Xi is the data. That's maybe summation from I equal to 1 to n. That's right. We have total number n. This is the average data. Right, for example, for this case, I show you we have the data is 1, 2, 3, 4, 5, 6 data. Right, 6 data. N equal to 6. Right, xi this for xi. That is talking the value. Right, the average is the summary of all data. You have to sum of this data divided by 6. That's right, divided by 6. That means this is the growth rate at 25 Celsius of sugar in water. 0.51, 55, 48, 54, 51, and 56. Right. It should be 0.51 plus 0.55 plus until 0.56. That's right. After you summarize this value, you get 3.15. That's right, 3.15. And then you divide this by 6. 3.15 divided by 6, you get 0.525. This is the average. And also I show you in this slide, we can use the Excel. That's right. If you have a big data, 100 data, 1000 data, difficult to calculate by the manual by you have. Okay, you can use the Excel or you can use the another program, right? Another program. In this case, we use Excel. And Ajahn Runsi will talk about the experimental design by using the Minitab. That's right. But for me, before midterm, I will apply only the Excel. I think I will show you the Excel for the calculation. Okay. We have at least 2 techniques by Excel. Right. The first technique you can use by the direct calculation. Okay? The first thing you have to sum of this value. You have called the built-in function sum. Okay, sum of this value. Right. Sum. You did sum equal to 3.15, and then you calculate by equal to the summary value divided by n equal to 6. You get the average value. Or another technique in Excel, we have the built-in function is the average. We use the average from Excel function. Right? Excel function, okay, equal to sum of this. Also, you get the same value. You have 2 techniques. You can call for the built-in function average function in Excel, or you use the calculator directly, or you summarize of all data and divided by the number of the data. Okay, and let's move to the next property. Right, for the next property is also the average, but for this case, if your data, if have the fluency data or the group data, as I for the fluency data, we have to modify the average formula from x bar equal to summation xi divided by x. In this case, you modify by summation fi xi divided by x. Fi is the frequency of your data. For example, right, if you count the number of people in the car, that's right, of people in the car that move across the traffic jam at time 9 to 10, for example. That's right, we have about 10 cars. That's right, car 1, 2, 3, 4, 4, 5. Okay, we have 5 cars. And number of people. Number of people is maybe one car is about 2 people, right? Sorry, I have some. Count the number of people, right? 2, 3, 4, 2, 3, 4, 5. That's right. We have the number of people. 2 people in the car. We count the number of cars that move across the traffic jam during 1 hour. Okay, we count it's maybe 5 cars, something like this. 3 people in the car. We have about 10. That's right. 4. We have about 10. 5. We have about outside 5. This is the number of cars that move across the traffic jam in 1 hour. We have totally 10, 20, and 30. 30 cars. That's right. In 30 cars. But for 30 cars, that's right, is 2 people in the car have 5. This is Fi. That's right. 5. Okay, for 3 people in the car, we have 10 cars. For example, this for the fluency. That's right, fluency. For example, we have 2 people in the car. We have 5 cars. Right. Also, I will show you the fluency for this data. For this data, that's why we have the value I equal to 1 to 13. And this is the strength. For this case, we check the property of material. That's right, material. This may be stainless steel, alloy. You check the strength, the property of the strength. That's right, the property of the strength. Okay, we have the strength value for each sample of the material. We have actually 13 material. That's right, 13 material. Not 13 material, is 18 material. This is the number equal to 18. That's right, number equal to ST. This is N. Right, this is N. Number equal to N. Okay, the strength of material equal to 435 is one piece of the material. And we have this one also one, but we have 2 pieces of material. That's right, 2 pieces of material. This material have the same value of strength is 475. That's right. This one for this case 518. That's right, 518 strength. We have 3 material. Right, these two. Okay, summary is 8. That's right. That means we have 2 material that have the same strength value. 3 material have the same strength value. 2 have the same strength value, and 2 have the same strength value. Another is only one. We call this is the fluency. That's right. Number of material, the fluency. Okay, from the formula, you calculate the average for this case. Average for this case, x bar equal to summary of Fi xi I equal to 1 until n divided by n. For Fi, this is Fi. Okay, Fi xi. This way you modify this way, you get this. This, you get this, and also you get this. Okay, and then this is the sum summary of Fi xi. And then divide this divided by 18, you get right? You get average. This is the average. Okay, this is for the calculate the average value for the group data that we have the fluency. That's why we have the fluency. It only modify this forms xi equal to summation xi divided by n. It's the individual for the group data. xi equal to x bar equal to xi fi. That's why it's only modify the value by fi. Right. Okay, so some like for this example, right, we have the number of material and this is the strength value. Right. Okay, for this case, you should be fi. This is fi multiply xi. That's right. This is for the first value. Then you can click this and to all value to get the value. This is multiply for each law. And then you sort of summation of this value, of this value. And then you calculate the average equal to this value divided by total number should be 80. You get the average is 488.5. This is the average strength. That's right, average strength for ST number of the material. That's right, number of material. Okay, this is for two techniques that you use to calculate the average value for individual data and for the group data, or for the fluency data. For the fluency data. Okay, for the next property that I will talk to you, I think if you remember when you studied in high school, mode, median, mean. I'm not sure in Thai, mode is the center value. I forgot the in Thai, I'm not sure. It's Mathya Than, Niyom, something like this. Okay, for mode, we have mode, median. Okay, mode, median. Okay, mode, what is the mode? Mode is represented by M. That's right, represented by M symbol. It's the mode fluency observed value of variable. That's right, it's the mode fluency. The mode means the number, the order fluency at the highest fluency. That's right, the highest fluency that we found in your data. If the mode for the group data is the midpoint of the model cell, or the midpoint of the mode fluency observed cell. If we back to this, that's right, what is the mode of this data? It should be 500 and ST, that's right, 500 and ST, because this is the mode fluency is 3, that's right. We have 1, 2, 3. 3 is the highest. That in the mode fluency is 3. For this case, 500 and 18 is the mode of this value because it's mode fluency. Right. This is the definition of the mode. If the data, that's right, in the group data, the mode is the midpoint of the model cell, which has the fluency is the highest. Right. Okay, for this case, the mode is 4. Why is 4? Because if you check by the mass rate number and number of defects, and the number of defects is the product that is failed. That side is failed. Okay, we have matter 1, 2, 3, 4, 5, 6, 7. 1 we have 3 defects. That's not 4 defects. 1, 2, 4, 0. What we have fluency is 4. That's right. Number of defects is 4 because we have 3. 1, 2, 3. 3 we have 1. 1 we have 1. 0 we have 1. And okay, the mode fluency is 4. For this case, the mode should be 4. That's right. The mode should be 4 because the mode fluency. Okay, for the group data, this is for the individual data. This for the group data. The group data, the mode is the middle cell. That's right. The middle value of the model cell. Okay, for this case, if you use the data with the group data, for this case is the mechanical engineering, mechanical engineer to record the flow rate of the liquid of some chemical. For this case, we measure the flow rate of the liquid. That's right, but we represent the data in the group data. Like we order from the minimum to the maximum value first. And then we have the flow rate between 7.5 to 7.8. We have only one frequency. 7.8 to S.15. S.1 to S.4 is 35, like this. And also we can see that the mode fluency is this cell, right? The mode fluency is 35. The value of the flow rate is between S.1 to S.4. As the definition of the mode for the group data, it should be midpoint of the model cell which has the highest fluency. Right. For this case, the cell should be S.1 to S.4, but the answer it should be midpoint. That's right. Midpoint should be S.4 at S.1 divided by 2. You get about S.25 liters per second. This is the most of this value of this data. But if the individual, okay, the highest frequency, if the group data, that's like the group data, is the middle point of the highest frequency of the group. This is the mode. And the next one, the property is median or median cell, median for individual, median cell for the group data, that's right, median cell for the group data. Okay. What is median? Median is the data that separate equal. That's like equal for it should be the middle point or middle data or the center data. Right? For the center data. If the group data, it should be median cell. That's right, median cell. Compute the cumulative frequency. You have to cumulative. You have to summarize the frequency. And we talk to you for the case. For this case, for example, if you order the data from the minimum to maximum, that's like 1, 2, 3, 5, 6. Like the median cell should be 4 at the center. That's right. Median is the main center. We separate a half and a half both sides, equal half. For that, this is the median. We call it the middle point or the middle value or the center value. Like this. Okay, for example, we have the stress value. That's right, the stress of the shaft. That's right, we have the shaft. Shaft, it should be if we have the mixing tank. We have the impeller, we have the motor. We call the shaft. That's right, we did impeller mixing tank, for example. This is the motor. That's right, the motor to drive the impeller to rotate. But the shaft is the connection between the motor and impeller. We call it the shaft. That's right. The most common for chemical engineering and petrochemical engineering. That's right, for the shaft to mix. That's right, in reactor in the mixing tank, something like this. Okay, for this case, we measure the stress of the shaft. The stress of the shaft, we have 7 shafts for a half-inch in diameter. We have 7 values of the stress of each shaft. Okay. For the first question, calculate the value of power per square inch. That's right. Okay, what is the maximum shear stress? What compute for? Okay. To find the median. That's right. This means the median value. What is the median value? And the second question, if we add one more, that's right, this property to this data, and what is the median value? That's right. What is the median value? And frequency, we talk about the frequency data. This is for question C. Calculate the median value or median set for this set. Okay, first we look at question A and question B first. Question A, you have to order the data from minimum to maximum. This is we have to order from, this is the minimum, that's right, 8,210 is the first one. The second one is 8,438. And the next one should be number 3, number 4, number 5, 6, 7. Okay, we order from the minimum to maximum value. For this, in fact, we get the minimum to maximum. Okay, the median data should be the center value. Okay, 1, 2, 3, 4, 5, 6, 7. That's right, median should be number 4. 1, 2, 3, 1, 2, 3. Okay, we call this is the median value. Okay, 8,560 pounds per square inch. Okay, for the next one, if the data we have this data, right? We have 8,150. We have 8 data, not 7. That's right. 1, 2, 3, 4. 1, 2, 3, 4. The median. That's right. This is the median because the median value is between 8,545, 8,560. This is the median value between these two values. You have to calculate the midpoint of these two values. Because the median is between these two values. Okay, we have to calculate the midpoint. It should be this value divided by 2. You get 8,552.5 pounds per square inch. This is the median value. Right, median value. For the next example, in the fluency data, that's right. For this case, you order from the minimum to maximum. This is the number of engineer, which is the F fluency data. That's right, fluency data. Okay. And then for this technique, you have to calculate the third column. This is the cumulative. That means cumulative. Okay. For 900 to 1,005, we have 5. 1,000 to 1,110. For this case, 5 plus 10. We get 50. That's right. And 1,101 to 2,000. That's right. This is 5 plus 10. 15 plus 15. That's right. We get 30. And also for this, 30 plus 35, we get 65. Right. And also for this, 65 plus 35. 65 plus 35. Sorry. 65 plus 85. Right. Get this value. And 150 plus 45. That's right. This for the cumulative, and finally you get 230. This is, that's right, total number of engineers. Total number of engineers. Because we sum all of this frequency, we get total. That's right, we get total. Okay. For the median, that's right, the middle point is 1, 2, 3, 4. 1, 2, 3, 4. That's right, the middle point should be between this value. 1,300 and 1,400. That's right. 1,300 and 1,400. Okay. This is I talked to you for this test. It should be between these two values. That's right, between these two values. Like this. This. Okay. This is for the median point. For the median, because it should be the midpoint of this. That's right, the midpoint of this. Okay. For the important next property, that's why we talk about the standard deviation or the variance. If we talk about the error data, that's why the error or the deviation from the mean, deviation from the two values. commonly we measure in terms of standard deviation. That's like the standard deviation. If we have high standard deviation or large value of standard deviation, this indicates that the high error, that's right, high error or a lot of data deviate from the mean. That's right. If the standard deviation is small, it's also low error or low dispersion from the value, from the average value. Right. For example, for this, we plot the histogram, the fluency and factor or variable. This is the small standard deviation. That's right, small standard deviation. This is for large standard deviation. Small standard deviation, that means your data. That's right, your data should be uniform in fluency. That's right, uniform in size, uniform in the factor. Right. If you plot in polygon, it is quite large distribution. This means higher deviation from the mean, low deviation from the mean. That's right. For this case, for the example, how to calculate the standard deviation or the variance. If we have the data, xi means the data. That's right. X bar means the average of the data. That's right. You can calculate average by summation xi divided by n. If you calculate standard deviation, you should calculate by square root of this term. Summation xi minus x bar square and divided by n minus 1. Xi is the individual data, x bar is the average of our data, n is the total number of data. So you can calculate by this value or by this formula or this formula. It's up to you. So you can calculate for both equation. And what is the value? Variance is variance. Okay, variance is the s square or the square of the standard deviation. That's right. This value, the standard deviation square, and standard deviation is the square root of value. That's right, square root of value. But sometimes you can represent this data by coefficient of the CV. That's right, coefficient of the variance or CV. The coefficient of the variance is the standard deviation divided by the mean. That's right, divided by the mean. Or you can represent in terms of percent. You calculate this value and then multiply by 100. This is the percent coefficient of value. That's right, percent coefficient of value. Also, if the higher CV, the higher deviation from the mean, lower CV, that means the lower deviation from the mean. That's right. This is for the value that we use to calculate the error or the dispersion of your data from the mean, for something like this. Okay, this is the definition of value that I talked to you. That's right. Variance is the square of the standard deviation, and the standard deviation is the square root of the value. This helps you. Okay, for this example, I give you to calculate the standard deviation and variance. We have is data. That's right. We have is data, and xi is your data. Okay, the mean you can calculate the mean either by taking, that's right, by the mean. Summarize of this value and divided by it, you get the mean. And the standard deviation for this case, you can calculate by summation xi minus x bar square divided by n minus 1 and square root of this. Right. Okay, for this case, we xi minus x bar. That's right. And xi minus x bar square. You sum of this value, that's right, sum of this value equal to 472. And then divided by n minus 1. N minus 1, s minus 1, you get 7. It should be square root of 472 divided by 7. That's right. Divided by 7, you get is 0.211. This is the standard deviation. How important this value? That's if you draw this line, we have the x bar. Okay, this x bar is the average 17. Okay, 17, and then you plot our data. This 4 is 13, 18, 19, 21, 25, and 28. But this is your average. You can see that the data is far from the average, like this, very far from the average. It's very far from the average. 4 and 28 is the highest error. Okay, for this case, you can represent the maximum and minimum. This is the maximum limit. This is the minimum limit, for example. For this case, we use the maximum and minimum by one standard deviation. Right? For one standard deviation or 86% confidence interval, 68% CI. For if you accept the error, maximum and minimum error is one standard deviation. One standard deviation is from the mean you pass x bar plus 8.211 and minimum s bar minus 8.211. That's right. If you control the property, okay, if the error is in the rank of 1 and minus standard deviation, you accept this error. If you accept this error, that means we have to 4 and 28 is out of your acceptance. For this case, you need reject for that case. If you use this data to control, that's why you use data to control. I will talk to you in detail for this a lot for the confidence interval. That's why confidence interval. It's very, very important when you collect your data. When you do the experiment, that's why the data is not the same exactly. There are errors that are the higher than mean, lower than mean. But we would like to talk what is the acceptance region that you accept for that case. For this case, we accept the one standard deviation. Maximum is plus one standard deviation. Minimum is minus one standard deviation. If your data is this length, okay, we accept this data. If the data is out of this length, we reject for this data. There are some errors. Okay. Like this, the repeat slide. Okay. I will give you some important example. For this case, had an engineer. That's right. Had an engineer take the sample from the production. We have 10 leading weight of the product in one day. That's right. In one day. And your spec, that's right. Product specification. The error should no more than 25%. That's right. 25%. The error should no more than 25% compared to the accepted region. That's right. Okay, for this case, we use only the one standard deviation. Right. One standard deviation is the limit for maximum and minimum. Okay, for this case, does this sample meet the specification? It meets the specification. We accept only 25% error. It's higher than 25. We do not accept. That's right. Okay, for this case, this is your data, the weight of the product. We have 10 products. Like 1, 2, 3, 4, 5 to 10. That's why we have the average. We have the weight of data. That's right. Okay. For this case, you have to calculate x bar. You have to calculate s and maximum minimum limit to x bar plus s. That's right. It's the maximum minimum limit. Okay. For this case, we calculate the summary. You get this, and then you can calculate the average. That's right. You can calculate the average. And for this case, we use to calculate the standard deviation. That's right. Calculate the standard deviation. You can use this formula, or you can use the formula. You can use this formula or this formula to calculate the standard deviation. Okay, for this case, we get the variance like this, and we get the standard deviation. In the Excel, we have to calculate by the formula, or you calculate by the built-in function from the Excel. We can use the STDEV from the Excel. That's right. Okay, for this case, we get the standard deviation is 7.04. That's right, 7.04. And the mean is 2,146 divided by 10. You get 214.6. This is the average. For this case, we accept only one standard deviation. x bar plus 1s, x bar minus 1s, x bar plus 7.04, x bar minus 5x04. For this case, the maximum value is 221.64. Minimum is 207.56 for that case. Okay, this is the maximum, right? The maximum, the minimum. Okay, we check your value. That's that you check your value. There are any value that's higher than the maximum or not? Okay, if we plot, right, this is the mean x bar. This is the maximum to 1.64. This is the minimum 207.56. Okay. This is in the length. Oh, sorry, this out of the length, right? Okay, in the length. 21. Okay, out of the length. Right, this is out of the length. Okay, we have three values. That's right. We have three values. 3 from 10. That means this is 30%. That's right. T value that's out of the length. That's right. We have one value lower than this, lower than 207, and two value is higher than 221. We have three value from 10 value. If we calculate percent, it's 30%. What does it mean? The 30% is out of the spec, do not meet the spec. But for this, we accept only 25. That's right. Okay, you accept the error is 25. That's larger than the minimum and maximum, only 25. But for this case, we get 35. What does it mean? In conclusion, the data do not meet the spec. Do not meet the spec because we accept only 25% or less than. But for this case, we get 30%. But it is your product is out of your spec. How to do it? You control the product. You have to go back to check your process. What happened? That's right. What happened? And then you improve your process. And then you check again. Is in the spec or not? For this case, the example when you work in the industry, if you would like to control your spec of your product before go to the market. That's right. Before go to the market. Okay. I think you can use this by yourself by the Excel. Excel by the Excel. Maybe I will show you. Okay. Have some Excel. Okay. You can calculate directly from the standard deviation like this formula is STDEV, and you pick all this data. That's right. Pick all this data, or you can calculate directly from the formula that I talked to you. That's right. That I talked to you. For the next example, from this example, we talk about the individual data. If we have the fluency data, that's right. You can calculate the standard deviation of variance for the fluency data. You only modify the equation, only like this. That's right. Only to add some the fluency in this term. Right. In this term, if you go back to the previous formula. Xi minus x bar. You can modify this equation is this. You can add fi in this equation for the fluency data. Okay. The formula is look like the same. You only modify some this term, the summation term. You add fi. You add fi. That's how you can calculate the standard deviation and variance. That's how standard deviation and variance for the group of data. Okay. For this example, right, you have the data. We have the group of data. We have S group of data. That's right. We have S group of data, and the xi for this case, you xi mean the middle of the group. If you calculate that, like xi and fi, xi is the middle point, middle point or the center value of the group. That's like the center of the group, and fi of the frequency. Right. Okay, for this case, if we know the x bar, s and s squared, you can calculate by Excel. For this, I show you by Excel. Right. Okay, this is your data, the group data, and then you have to calculate the midpoint because xi for this case should be midpoint. Because the group data we have a lot of data. Okay, the calculation you have to use the midpoint of the data. Okay, the midpoint is 17 for this. It should be 15.5 plus 18.5 divided by 2. You get 17, which is the midpoint for each group. Midpoint for each group, and this is for the frequency for each group. Frequency for each group. I think please remember that when you talk about the group of data, you have to order from the minimum to maximum first before to calculate for that. That is easy for you. Okay, you know xi, you know fi, and then you calculate, follow this formula, summation fi xi square, that's right, minus this term x bar square. Okay, this is fi xi, that's right, this couple. Okay, and then this is xi square, right? Xi square, right. fi xi square. Sorry. Okay. Okay, this is xi square. You have many formula, but for this case you use only like fi xi square. That's right, fi xi square. Fi xi square. You get fi xi square, and then you can calculate the standard deviation. Right. Summation fi xi square divided by n minus 1 minus n divided by n minus 1 x bar square, and take the square root. Then you use only this column. That's right. Summation xi is this value. That's like 3,5,3,6,5,2 divided n minus 1 divided by 7. That's like divided 7. And I forgot n divided n minus 1. N, sorry. Minus n divided n minus 1 x bar square. That's right. Take the square root. You get standard deviation. You get this value. Get this value. Okay. And then you can calculate this by the frequency data or individual data. Like from conclusion, you get the x bar for this s, right, and s square. S square means the standard variance. You can calculate the mean, calculate the standard deviation, calculate the variance of this data. Okay, for conclusion, I would like to talk to you in more the data. We have two types of data: individual data and group of data. In the group of data, you have to determine the frequency. That's right, the frequency, and then you can calculate average, standard deviation, the variance of the individual data and group of data. I will talk to you in this, that's right, in this lecture. And also the last one is the lag estimation of the error, the length. This is the maximum minus minimum. This is also you can use this value to calculate the error, that's right, to determine the dispersion or determine the deviation from the mean. But for this case, it's not common use. That's right, not common use because it's not inaccurate technique, because this is the inaccurate technique. The common use should be use the standard deviation or value to determine the dispersion of the data. That's right. But the length is not common, and also is inaccurate technique for that. Okay, for this is the most of the introduction about the property of data that I will talk to you.